Thank you, Jelly. Good evening, everyone. My name is Karim Atif, and I'm the chair of the IIRSM branch in Egypt. Welcome to the 12th IIRSM branch meeting in Egypt. Our guest speaker today is Andrew Hornby. Andrew is a chartered construction manager with 25 years consultancy experience leading strategic health and safety solutions in design, procurement, and construction. Andrew's current role is a global one, and he is involved within the governance and assurance of health and safety on projects in Egypt and elsewhere across the region. Andrew is based in the UK, where he has served on regional and national council of Association for Project Safety since 1999. He is a member of the IIRSM and the IIRSM, and a certified member of the APS, and a fellow of both the Chartered Institute of Building and Royal Society for Public Health. Our agenda for today's meeting will be, firstly, I will speak about our branch updates. After that, we will listen to Andrew, who will be presenting on safety in design. Finally, there is a Q&A session, so if you have any comments regarding to the topic of the webinar, feel free to submit it in the question box, and we will answer all your questions before the end of the meeting. Regarding to our branch updates, the 2023 IIRSM Risk Excellence Awards. The IIRSM Awards celebrate risk excellence and all those who contribute to protecting people, reputations, and profits. The awards identify those organizations, teams, and individuals that champion better risk and safety management to drive organizational and employee well-being. The awards are independent and free to enter for both the IIRSM members and non-members. Whether you work for a large multinational company with big budgets and lots of resources, or an SME or a charity with limited resources, the principles and the benefits of effectively managing risk equally apply. The independent judging panel consists of international risk and safety and business professionals from a range of backgrounds and industries. Please feel free to visit the IIRSM website and check the different awards category. There are, I think, 9 categories, including a new category related to the Best Diversity, Equity, and Inclusivity Strategy of the Year. And if you need to participate, submit your entry application form by email no later than 4 p.m. on the 3rd of February 2023 UK time. Regarding to our future branch meeting, as usual, our meeting will be on monthly basis. The next branch meeting will be on the 8th of November. The topic and the speaker will be confirmed shortly. And regarding to the CPD and training opportunities, the IIRSM will deliver an online workshop on the construction design management, the CDM, and building safety. The duration of the workshop is 6 hours, which is split into 2 consecutive days. The course will be on the 19th and 20th of October from 9 to 12 p.m. UK time. This virtual workshop provides construction and property professionals with an understanding of best practice of the CDM 2015 techniques, how to demonstrate good and compliant design through the design risk management process, and the key aspects of the new Building Safety Act and its secondary regulation, which is being drafted. The requirements and the relationship between both the legislations is discussed, along with how compliance with both can be practically achieved. So for more information about the course and the booking, Julie will share the link in the chat box. Regarding to the international branch meetings, there will be 4 upcoming branch meetings that will be delivered in October. The first one is the UAE branch meeting, which will be on the 20th of October. Branko Denenberg will be presenting on sustainable construction and the role of HSE professional. The second one is Qatar branch meeting, which will be on the 25th of October. And the third one is India branch meeting, which will be on the 26th of October. Madhukar Tiwari will be presenting on design and basic engineering principles of industrial scaffolding. The fourth one is the Pakistan branch meeting, which will be on the 27th of October. And regarding to the UK branch meeting, there will be upcoming 3 branch meetings that will be delivered in October. The first one is Yorkshire branch meeting, which will be on the 19th of October. And the second one is London branch meeting, which will be also on the 19th of October. Mr. Ray Sykes will be presenting on emergency planning and business continuity management. And the third one is Scotland branch meeting, which will be on the 31st of October. So you can visit the IIRSM website to find out more information about the mentioned meetings, along how to register for those meetings. So that's the update regarding to our branch. So now I will hand over the meeting to Andrew, who will be presenting on safety in design.
Thank you, Kareem. Thank you for a very kind introduction. Julie, if we go on to the first slide, which is the agenda for tonight, I'm going to talk about the what, the when, the why, and the how of safety in design, and then give you some examples of what we've seen out in the field. Some of these examples that have just picked up off the internet. I don't own the copyrights to any of the images you see, but I'm indebted to whoever has created them in the first place. But if we then, I'm going to keep on saying next because I don't have the control. So Julie, thank you very much. Okay, so what is design health and safety risk management? Well, it's about the consideration of all the things that could impact on the health, safety or welfare of anybody arising from your project. So we're talking about construction projects that might be anything from hanging a door to building a data center or a railway bridge or knocking down a house, whatever it might be. And when we think about health and safety risks in the design, we're thinking about risks that could affect anybody during the construction of the asset or structure, during its maintenance, during its operation, just people using a completed building, or even using a building while it's having construction work done. We're also thinking further ahead to one day when that building or structure will be demolished or dismantled and ultimately disposed of. So we need to consider all the things that might present a significant and foreseeable risk to people that might be affected at any point in its life cycle. And also the point of what we're talking about today is getting that thought process and that decision making integrated into the design process. Next. So when do we do this? When should we be thinking about safety in design? Well, as soon as possible. As soon as the project starts in its inception, that is a time to start making a difference. That is the time to make those judgments and take into consideration the relevant hazards and assess the risks to health and safety. And as you can see from the graph there, the sooner you make a start on that, the greater the ability to influence the safety of the design. The orange curve there shows you that ability to influence decreasing as time goes by, while the dark blue line coming up demonstrates that there's the cost to manage those risks gets more and more the longer that time goes by. So there's a special point at which on the next slide you'll see that there's a special point at which those two lines cross, and that is if we look at the RIBA work stages across the top that start from a strategic inception through project preparation and briefing, concept design, design development, and then technical design. It's at that point of technical design when all the designs come together, your structural, your architectural, your acoustic, your mechanical, everything comes together. And after they're fixed and you go out to tender, that's the time that it will suddenly become very expensive to make those changes. If you haven't already considered the risks, it's after that point that things will be much more expensive to manage. And obviously that takes you into the construction stage and then handover and then in use. And they say that for every dollar that you spend on design, you'll be spending another $20 on building it and another $250 on operating it. So if you were to make design decisions earlier on, the money you'd save in the long term is very significant. So that's why we start looking at safety in design at the beginning of the design stage, and gradually, as the designs come together, we're in a position to just provide information to people as to how they're going to manage the designs. Okay, next. Why do we do it? Why are we interested in safety in design? Well, very simply, we want to keep people safe. Those construction workers, maintenance workers, building users, maybe customers or other members of the public, anybody could be affected by the project and the construction risks associated with it. And there are, like all safety considerations, moral, economic and legal reasons. If we don't understand the risks, we can't manage them. If we can't manage risks, there's more likelihood of an incident, maybe leading to injury or ill health, and possibly even a fatal injury. By doing our best to protect people from harm, we can, as well as avoiding the suffering that applies to families, the impact of those incidents, there's also other things to take into consideration, like lost working time. If you've had an incident on your project and somebody is off sick, they can't work on it. That's going to cost you time. If some equipment has been damaged or the asset has been damaged through the incident, again, that is going to take time. Those program delays, they all cost money. And associated with that is business disruption and potential damage to your brand reputation for your business. And that's before anybody thinks about legal interventions, whether that's a civil claim taken against a business by a worker or member of the public who is injured, or whether it's a prosecution by your local enforcing authority. Next. So those are the reasons why we do this. How do we do it? It's about people getting together, getting the right people to talk to each other, get involved with each other, and help make those decisions. An architect doesn't necessarily know all the answers to all the questions and will need the help of a specialist such as a engineer, mechanical engineer, facilities management team, people that use the actual building that you're working on, specialist designers who are involved in things outside the scope of a regular architect's expertise. And also it's really important, if possible, to involve a main contractor early on. They know how to build buildings. They know how to manage the risks that they typically see. If you can talk to them about the risks that you're looking at, they can give you some really good advice early on. But it's all about cooperation, coordination, and those other words that all begin with a C just there. Next. So what are the things that we're going to consider as a designer or as a project manager even responsible for the design of a project? Well, as I mentioned earlier on, it's about identifying the hazards. And here's just a checklist of some typical things that just need to be considered. So about your existing building, or what you're going to do with your building, or maybe it's an empty site, but you still need to take things into consideration like ground conditions or contamination or whatever. The whole range of hazards which might be relevant on your project, and you should think about them and see whether or not they're worthy of further assessment in terms of risk. You can look at those in your own time after the presentation. So we'll go to the next slide, which breaks it down, breaks those the pre-construction stages into different areas, and we can talk about the things that we would be doing in each phase. So in the pre-design phase, when you're thinking about having a building built, you're thinking about starting a project, you might be doing a feasibility study or something like that. There's an opportunity there to think about some really basic hazards or potential risks and deal with them right there and then. You've got a potential site. You've got to put a building on it. This is the time to consider whether there are any hazards on that site which you might want to avoid. For example, if there's contaminated land on the site, this is the opportunity to say, well, let's place our building away from that contamination or on that contamination. That's your choice as a client or as a project team or design team. That is a choice to be made, and that's a critical one because it's a big decision, and there are other hazards, not just contaminated land, but the proximity to a railway, for example, or the proximity to a school, or your location within a shopping mall. There are all types of things which could present significant risks to the project and how it is, and the impact of how it is managed. So those are some things to take in at that stage. And as on the right-hand side, you can see some other examples: geology, emissions, other things associated with those very first decisions. I'll give you an example. I went to a building some years ago in India, where the client had bought an existing building and was going to use it for their own purposes, and they hadn't really taken into consideration the fact that the existing lifts, elevators, would not be able to cope with the number of people that they wanted to have in the building at one time. The building, the size of the building, could cope with the number of people they wanted to put in it, but the existing lifts didn't. And so they did the refurbishment work. They brought all the people to work in this new building or into this refurbished building, but the existing lifts were so small and so slow that there was, at peak hours of the day, there was too many people crowding in the lift lobby in the ground floor, and then at the end of the day queuing in the lift lobbies and the upper floors, which made those areas unsafe in the event of an emergency, and also uncomfortable and unpleasant for people to be working in those conditions. So if somebody had thought about that as a potential risk when they were considering buying that property, they could have made a different decision. Or they could have taken it into account and said, when we refurbish this building, we're going to have to make the lifts bigger and faster to mitigate that risk. So that's just a very simple example. When you move on to your conceptual and schematic design or your preliminary design, there are other kind of risks to be identified, such as how you're going to build it, what you're going to install, how you're thinking about possibly maintaining the building in the future, and one day the disposal or demolition. So, for example, if you're thinking of using pre-stressed or pre-tensioned components, you've got to think that one day we're going to have to take this down. Will that be able to be done safely? And so this is a time when you think about the specification of materials and components that you'll be putting into your building, any particular areas of the building which might be difficult to build, access arrangements for maintenance are also really important to consider at this stage as well. And then, what is it if we're designing somewhere as a workplace, what have we got to consider in terms of making workspaces suitable for people to work in the future, because this is the opportunity to design them right. And then the third phase, the bottom of that picture there, is about detailed design, which is making sure there aren't any clashes between your structural and your mechanical and so on parts of the design, and thinking about those residual risks, which they're in your risk register now, but you've not designed them out yet. This is the last opportunity really to pull it all together and make sure that they've been properly considered. So, for example, if you're looking at a building where you might be able to employ the use of precast concrete stairs, for example, you might think to yourself, well, let's put those in at the beginning of the job rather than just rely on ladders throughout the construction process. We can put the actual finished stairs in first to give construction workers safe access up and down between floors. Better still, let's specify those precast stairs that have handrails on, so that when the construction workers are going up and down, there's less risk of them falling. Okay, next. So this is a very simple risk assessment matrix. I'm sure you're all familiar with this kind of thing. It's the way we do this is we consider all those potential hazards. We look at the risks that are presented, those foreseeable significant risks that are going to be different or big or difficult to manage, and we work out, whether we consider those, low or high or whatever. However you typically manage risk or assess risk, you can use a very simple matrix for working out which risks are the ones that we really need to focus on, and which risks, when you address them, will have an impact on something else. Let's go next. And the idea is to eliminate the most significant risks. That's the best way of dealing with risk, is to avoid it, eliminate it. Obviously, if we can't eliminate it, we need to reduce it in some way. And the way of doing that is set out here. It's the hierarchy of risk control, the principles of prevention. Call it what you like there, but it's about using that process of decision making to, if you can, eliminate the hazard. If you can't, let's reduce it in some way. And pretty much the bottom line is, if we can't physically avoid or reduce it, we need to be providing information to people, and then some other arrange for the contractor to make their own controls to manage the risk, but you have to provide them with the information on that. Okay, next. So we have to provide information about the residual risks. So hopefully you've gone through the design process, you've identified all the significant hazards, you've assessed the risks and the ones which are significant and foreseeable, work to design those out, and we'll have a few clues about that later on, but we'll look at designing those out. And where we can't design them out completely, and there is still some kind of residual risk, we need to share that. We need to share that with other members of the project and design team, so that everybody is aware of what those risks are. But also we need to share with the main contractor, the general contractor, who is going to come and do the work. Why do we share it with the contractor? Well, because they're pricing the job. If you want them to price it properly, they will need to know about the risks that they have to manage. How much is it going to cost them to make special adaptations, or bring in special equipment, or work in a special way to avoid injury or ill health to themselves, their workers, or other people? So it's important that we provide that information. And one of the ways you can do that is to put notes on drawings. And on the top there's just an example with some, you won't be able to read the detail, but you can see there are some yellow triangles highlighting different types of risks that the contractor needs to take into account. And there's a little example of the key there of what they're about. The picture below is a demonstration of Revit, where you can tag, you can use a software to tag risk areas or hazards inside a drawing that relate back to your risk register. Next. This is another example. This is a drawing which has been marked up, clearly setting out where the hazards are and what kind of risks are presented, and what the contractor or others will need to do to manage those risks and keep themselves safe. So in there, for example, they've noted that there's a place for the welfare facilities to be set up on the site, and the designer has thought of that in advance and said, well, this area here has got, you know, power, it's got water, it's got drainage, and it's out of the way, really good place to put up your welfare, toilets, washing, canteen, that kind of thing, except that at one point during the course of the construction process, we'll have to move it from there. So here is another temporary place for you to put your welfare facilities while we do work in that other area in the short term. So thinking about those kinds of things, giving the contractor some help. You don't need to, you know, where there are residual risks, it's down to the contractor to manage them, but it's only right that the project team give that contractor enough information to go on next. So I'm going to give you some examples now of where at the project design and planning stage we can make a difference. So this couple of pictures here on the left, somebody is or a couple of people are working there in very noisy and dusty conditions, breaking down pile caps by hand. So concrete pile caps, they're using a pneumatic drill, so they're at other health risks there as well, apart from noise and silica dust. They're also at risk from hand-arm vibration and the associated complications that brings. Picture on the right shows that on this project, the designers have specified the use of mechanical equipment to chop off the top of the pile. So it doesn't have to be done by hand. It's done remotely by somebody in a machine who's safe enough to do that work quickly. Yeah, it'll be more expensive because it's a big machine, but it's not going to cost that worker their livelihood. Next. Another from construction, I mentioned construction projects where access between floors is always by ladders. Well, actually, if you can design the permanent works, the precast staircase units to go in as soon as possible in the superstructure, then you can save the risk of people falling and slipping on ladders, the problems associated with climbing ladders and carrying tools at the same time, and it makes it a much safer environment. And in this particular example on the right, the contractor has provided temporary handrails made out of scaffolding. Well, that's quite good, but wouldn't it be even better if they come from the factory with a ready installed handrail as well? Next. Again, this is about the construction process and slinging of steelwork. When you're putting up steelwork, depending on your crane driver and depending on the slinger who's loading the load, things can get a little bit out of hand when you have a load in the air. So at design stage, what we can do is we can specify the steelwork to have the lifting lugs. That middle picture there is that's where the crane can put their hook into that piece of steel to lift it up, and that will make a real difference to how that load can be controlled. And while we're at our drawing board designing our steelwork and thinking about doing that, we could also think about having hooks fitted on our steelwork that when it's erected, you can straight away attach your safety nets to. So if you're working on a construction project which has safety nets to protect the lives of steel workers, somebody has to go and. Oh, I'm back again. Kareem, can you confirm?
Andrew. Yeah,
Good.
we can hear you. Thank you.
Right, sorry about that. So that's still work. Let's move on to the next slide and see another couple of examples. So again, this is about a decision that you can make at a steel platform there on the left hand side, and it's been installed. Somebody is now trying to put in some edge protection, some brackets there to hold a handrail. Well, how about you specifying that steel work with a handrail already fitted to it, like the picture on the right? That means that somebody hasn't got to work at height to fit that handrail on. It comes off the back of a truck, goes onto a crane, gets installed straight away, and immediately it's safe to use. Next. And how about this? A hole in a floor void, a hole in a concrete slab. There was an incident I was looking at recently where somebody had accidentally stepped back onto that because it hadn't been protected. They fell 3 meters and received some very serious and life-threatening injuries, but they did live to tell the tale. A designer designed that. Well, I would say the designer could have designed the option in the middle, which includes keeping the reinforcing bars in that void when you cast the void. You can see on the right, the picture there, that worker is standing not in midair, they are actually standing on the reinforcing bar, which is strong enough to hold them should it need to during the course of the construction work. And at the very last moment, when that void will be needed for a duct or a stair or whatever might be going in there, they can then cut the rebar out. But it means that for the whole 9 months of construction, it means there isn't a risk of somebody falling to the floor below. Next. This is one of my real pet dislikes, is unnecessary chasing of concrete or masonry. There's no need for it. It creates so much dust, silica dust, which is really very bad for everybody's health. And with a bit of thought, it shouldn't be necessary. The picture on the right, for example, you can see there are dabs there ready for somebody to put plasterboard over the top. And so your cables or whatever you are chasing into the wall could be just attached, surface mounted to the wall with your plasterboard over the top, or whatever it might be that you're using. So there shouldn't be any need to chase into masonry. It's very hazardous in terms of the dust. There's also a lot of noise. There's also a lot of vibration. So it's not just for construction workers, but other people who are in the vicinity could be adversely affected by doing that. The next picture also looks at chasing concrete. Again, completely unnecessary when we have the technology on the right-hand side of these cast-in channels, where that top picture shows the channel that is going to be cast into the concrete. So when that concrete is laid, it means the channel will be there, formed around that piece. And the bottom picture shows you even more different ways of casting in different channels and components and fittings. You know, it's really good. It might cost a little bit more money, take a little bit more time to think about what you want, but gosh, it certainly saves the construction worker the noise, the dust, and the vibration. And these considerations, thank you, these considerations aren't there to stifle good design. This is a project in the UK. As you can see, it's a very unusual shaped building. It's built completely of brick. The basic bricks, there are 46 varieties of what we might consider normal bricks, but there are 127 varieties of bricks which are specially shaped, specially designed for this project. And this means that out of 175,000 bricks, none of them had to be cut. No workers were at risk from brick dust, from vibration, from cutting themselves on a saw, and the noise and so on. So it can be done. So designing for safety does not need to stifle good design. So again, cutting masonry, you know, we see people cutting bricks and blocks, especially in external works, paving and so on. The top picture there on the left, you can see there's a channel that's been cut right in the middle of a row of slabs. There was no need for that. The channel could have been moved to the left, or the slabs could have been moved to the right. There's a bit of design that somebody could have considered when they were on the drawing board. I mean, how many slabs is that's been cut? Hundreds, probably. And there are alternative ways of doing it, and by considering the size of the components in your design, you can really make a difference. Picture on the right shows that instead of having to cut half slabs to fit the pattern, they've just used bricks which didn't need to be cut. The bottom left picture, this is a tree planter in the middle of a pavement. Well, it's a circular tree planter, very nice, but it means that because it doesn't match the pattern of the brickwork, how many of those bricks have had to be cut? Probably by hand, and again, dust, noise, vibration, and so on. Whereas on the right, the solution was to use a brick pattern that matched the existing paving, and so much less cutting. Next on, we'll talk about curbs. People on the left-hand side are having to lift up heavy concrete curbs. The man on the top right, he's not really very strong. If you look at the bottom picture, it's actually a hollow curb made out of glass reinforced plastic or some similar product. If it can do the job, why not specify that? When you're on the drawing board, or you're in your design team meeting or project meeting, these are the times you can make these suggestions and the decisions. The next picture is about the hazards of rebar, reinforcement bars. Picture on the left, anybody could fall on those spikes and be terribly, terribly injured. On the right, in the middle, the picture shows them being covered up by various means. But look, on the right-hand side, you can see that the structural engineer has specified rebar that folds over, so there are no protruding spikes. Brilliant idea, lovely piece of design work to keep people safe. The next picture is looking at chimneys. We have these on the top of our houses in some areas to let out smoke from a fire. On the left-hand side, that's if somebody stood on their roof having to work very high up. In this particular case, they've not got themselves any edge protection, but either way, it's still a dangerous place to work. The middle picture shows you that you can buy these, specify these pre-formed, pre-made. They're built in a factory under factory conditions, and all that's got to happen is a half an hour job of installing that on the top of your roof, as opposed to a worker having to be up there all day long building it from scratch. Similar principle in the next slide, where we look at dormer windows with a window in the roof. Often very difficult to access, to build or to finish off, as the worker on the bottom left shows. Well, actually, we can buy these pre-formed, ready assembled, built in factory conditions. All that can be specified at the design stage. The next picture is looking at installing curtain walling. These people are having to do it from the inside manually, no edge protection, which is the way they're choosing to manage it. But the picture on the right shows that somebody's put some real thought into how they're going to install these panels from the inside with a special machine, edge protection in place to keep people safe. That was specified at the design stage. And we should think about operation and maintenance as well, which is the next slide. Installing a light that you can't reach to turn on or off isn't very helpful. Somebody could have made that a better choice at the design stage. How's somebody going to change that lamp? The right-hand side, the picture, you can see that those lamps have a motor on the top. Those lamps, you press a button at ground level and they will descend down to meet you for you to put in new light bulbs and so on. Just very quickly flick through the next few slides. This one is edge protection on the left. Someone's done a retrofit edge protection that could have been designed in. And on the right, you can see that it's been designed in because with actual railings on the steelwork. Next picture is fragile roof lights. If you've got fragile roof lights on your existing building, one of the things you can do is put a cage around them so that during the construction work or in future maintenance in 5 years' time, people aren't going to fall through and hurt themselves. The next one we'll look at is some facilities maintenance and engineering. Those people on the left aren't going to be able to reach the valves for their equipment, but on the right hand side they've been given a very nice place to do their work outside, protected from the weather. So those are construction, operation and maintenance. This set of pictures here, it looks absolutely crazy, but these are examples of poor design or ill-considered design in use. You can look at all these pictures on the internet and it looks quite funny, but the next slide is a bit more serious. This happened in the UK. This was a newly designed building, and the thoughts that we're talking about, the considerations that we've been speaking about tonight weren't followed. Somebody didn't consider how this design might affect somebody. As it was, a maintenance worker was coming down the ladder, came down the ladder, and you can see there isn't enough room behind the ladder for them to do much. So they got off the ladder, stumbled backwards, tripped over that edge, and fell to their death. Very tragic. Very tragic for that person and for their family. Obviously, a big impact on the project. Sorry, not on the project, but on the building owner and the building users. This was a completed building, and also big impact on the organisations, architect and contractor, who were taken to court and prosecuted for basically creating the circumstances that led to that worker's death. So it is really serious, and this is why things should be considered. I won't go through the next slides apart from telling you that there are opportunities for you to specify the things that you want to avoid. So we have these red lists and amber lists over the next two slides, which just show you the things that you can avoid and consider during the design stages. You can say that actually we were going to make sure our project doesn't include these things or definitely avoids them to keep people safe. And in these orange ones, the amber ones, sorry, it might be just things that you want to reduce as much as possible. The green list on the next page shows you some things you might want to positively encourage, which is some of the ideas that I've shared with you today. So finally, in summary, just want to scope back about what we've covered. We need to consider health and safety risks right from the inception of the project, have the right people involved in the discussions, specialist contractors and designers and so on, have people cooperating and communicating, and make sure we provide the right information to the people that need it, the building contractors, for example. And it's not just, we're not just designing for health and safety in construction, but also for the whole future life cycle of the building, for its commissioning, its fit out, how it's going to be used as a workplace, how someone's going to clean and maintain it, and then what's going to happen when we carry out future alterations or refurbishment or even demolish it. We've got an opportunity right at the beginning and for the whole of the design phase to make some really valuable decisions. So that's what it's all about. It's consideration of those design risks and integrating them into the management and delivery of your project. Thank you.
So Julie, if you have any questions regarding to
No, we don't have any questions yet. So if anybody's got any questions, if you want to pop them in the questions area, and we can get Andrew to answer those for you. Do you have any questions, Kareem?
Yes, regarding to the pre-construction opportunities, is there some standard or something that clarifies some checklists for the items to be considered in each phase during the design of the project?
Good question, Kareem. It does depend. So in some countries, what we're talking about today is a legal requirement to make these considerations. But even then, people typically don't specify. So you'd have to look at local codes to see if there's anything about that. But the examples that are shared in the last 3 slides, those red, amber, and green lists, they're a good place to start. They were created in the UK by the enforcing authority, the Health and Safety Executive, just as guidance. So it wasn't a legal requirement, but they proposed those, 10-15 years ago probably. They've not been published since then, but it's a good place to start. And there's similar with one of the other checklists I put at the beginning. So it's down to the designers and the project team to think through it themselves, a bit like in any other aspects of business related health and safety. It's down to you to assess the risk, and so it's very much down to the individuals involved and their judgment.
We've had a question come in. How can this relate to process safety management? That's from Adele.
Okay, so I'm talking just about design and construction here, but in terms of if I'm understanding the question correctly, you could apply the same principles to any other aspect of design or engineering. I think the principles, if you look at them, should be applied to anything. But I don't know if that answers the question.
Okay, thank you. Perhaps Adele will let us know. That's it for the questions, Kareem. So back over to you.
So thank you for everyone who attends our branch meeting. And as usual, you are saying, feel free to bring on your wider network to join us in our future branch meeting. Also, I would like to thank you, Andrew, for accepting our invitation to speak in this informative session. Thank you.
Thank you, Kareem.
Yeah, thank you, Andrew. And Adele's just confirmed, yes, thank you. It did answer his question. So I'd like to thank Andrew and Kareem for organising this evening's presentation. I'd like to thank everyone for attending. And just to remind everyone, your CPD certificates will come out this time tomorrow, and the recording will be on the IIRSM YouTube tomorrow. So I'd like to wish everyone a good evening, and we hope to see you at the next branch meeting. Good night, everyone.
Thank you, Julie.